and welcome to episode 34 of the Primary Maths podcast, the show where we talk all things primary maths. I'm Jon Cripwell.
And I'm Becky Brown.
Yeah, you are. Becky, you're back.
I'm back.
We missed you.
I missed you.
You didn't have a voice, did you, last week, which makes it quite difficult to do a podcast.
Yeah, no voice whatsoever. And I have had sore throats before and been a bit croaky, but this was just nothing.
A complete lack of voice. Yeah.
Yeah.
You did join me for some online PD at one point, and just sort of had to sit there in silence and sort
Smiled
of nod.
encouragingly.
Exactly, yeah, and I appreciated the moral support.
It made things a little bit difficult, yes.
It did. But you are back, and we have got a packed AfterMaths episode today. So we are going to be doing a little bit of history of maths, which, you know, we love to do. We're also going to talk about our own personal top 3 trickiest things to teach in maths, because I was thinking about this last week when I was working with some skit students about the trickiest things to teach. So it'll be interesting to see whether we align on those things, Becky. I know you've got a maths of life that we can talk about as well. And of course, we've got the key takeaways from Phil Hurd's episode on problem solving from earlier this week. So if you haven't heard that one, go back and give it a listen. And while you're there, just if you haven't already, give us a like, give us a subscribe, and make sure that you don't miss any episodes. So without further ado, I think we'll jump straight into it. Did you, just before we get into the history of maths, so Becky, did you see Keir Starmer joining in with our favourite craze this week at all?
No, I didn't. I saw it on I'm a Celebrity. I didn't see Keir Starmer. That probably tells you a little bit about my viewing.
Yeah, I haven't been watching I'm a Celebrity this year. I have very little time for non-maths related things generally, but very little time to watch TV. I tend to watch maybe an hour of TV a night, something like that, maybe 45 minutes. So yeah, I have to be very selective. But all over social media at the moment, Keir Starmer was visiting a school. I don't know which school. I don't know whereabouts in the country. I don't really know why he was there. But he was sat next to, if you've not seen it, just have a look for it. He was sat next to a girl who was showing him her reading book, she was very keen to get to page 67 so that she could do the whole 6-7 meme. And Keir, bless him, was clearly familiar with this because he joined in straight with it, disrupted the entire class. The whole class then started joining in, stopped doing whatever they were supposed to be doing with all these adults and a film crew in the room and things, and just started doing the 6-7 meme instead. So yeah, I just thought if I was the head teacher or the teacher there, I'm just thinking this is just, we're supposed to be, clearly that was not the reason that he was there in the classroom in the school. They obviously had a different agenda, but kids being kids, they saw their opportunity and they went with it. But I did feel for the adults.
We know they're good at that.
Yeah, I did feel for the adults. I just thought that this was not how you imagined this prestigious event would go. And I think,
maybe they've got a little bit more coverage than they maybe would have done.
Probably, just not for the reason that they were hoping for. But he did apparently apologise to the head teacher afterwards for completely disrupting the lesson. But yeah, you know what it's like when you've got an important visitor coming around. You just want everything to be, everybody on task. You give the kids that talk, don't you, as well, before they come around? We've got a really important visitor coming in. Just keep it together, guys. Just keep it together for 10 minutes. And then, it wasn't the class's fault. I'm squarely placing the blame on the Prime Minister there for joining it. But yeah, do have a look because it's very funny. Just as soon as he starts doing it, it feels like there's a license then for everybody to join in. So yeah.
Oh dear.
Yeah, bless them. But, we love a little bit of history on the podcast. And we did go into the history of the 6-7 meme a little bit. We did. So if you do want to know where that came from, you just need to go back and find that episode, which I think was probably about episode 28, something around there anyway, 27, 28, something like that. But I was we've done segments on the history of zero, and I was talking to a guest who we'll have on the show next week, Rob Eastaway, who's brilliant, who's written a lot about the history of maths, and he was talking about Roman numerals as well, correcting me a little bit on something that we said on the podcast last week about Roman numerals. Not really
Okay.
correcting, just elaborating. Let's put it that way, elaborating on what we said about Roman numerals, and it got me thinking about other things that, maybe we take for granted now, but weren't always around and not always part of maths. And one of those things is the equals sign. So it's ubiquitous, isn't it? It's one of the first things that we introduce in reception, maybe even
Yeah.
earlier if you're, in a nursery setting, you potentially children come across it before that. But we introduce it definitely in reception, and I think we're very good these days at saying that this is the equal sign, but it means the same as, doesn't it? It's wherever we
Yeah.
see it, and I think we've got much better than when I was at school as a pupil at putting the equal sign sometimes at the start of an equation, sometimes at the end. We're getting this idea that it doesn't have to go at the end, and it can mean different things. But how long, Becky? I said in a meeting this morning, I put you on the
Oh,
spot
no.
today. How long do you think the equal sign has been around for?
Oh, John, why'd you do this to me?
Because I'm
Okay.
mean. Yeah.
I think it might have been around. Well, I'm going to say something
Everyone else
ridiculous.
was talking amongst yourselves for a minute.
I
It's fine.
think
Becky's having a think.
150 years.
150 years. So that would take us back to what, 1775, something around that. Is that right? No, 1875. Oh my word. Oh
We
dear.
are in the 2000s now, sorry.
Yes. Yeah. Yeah.
Yeah, I
Eh,
mean, that doesn't feel like long enough, but I'm sort of I don't know. I was either going to go one way or the other, and that's the way I've decided to go
that's
today.
fine.
I better pick the wrong way.
You should go with your gut and stick with it. It's really important. It's been around a little bit longer than that in the way that
Oh, no.
we accept it. So, um, the actual idea of equals, so saying equal to, or written as an abbreviation in the Greek of AEQ, or sometimes abbreviated just to AE, has been around since about 250 AD. So quite a long time, quite a long time. But that's not what we're talking about. We're talking about the equal sign, the symbol.
Yeah.
So that has been around a much shorter time, still a little bit longer than 150 years though. So it was actually first recorded by a Welsh mathematician called Robert Recorde, or Recorde, I don't know. It's record with an E on the end of it. In his seminal work, which I know you'll be familiar with, Becky, The Whetstone of Wit, in 1557, which was,
Oh, okay.
yeah, it was one of the last things he did because he died a year later. And
His work was done.
yeah, his work was done. Yeah, his work was done. So he was the first one, as far as we can tell, he was the first one to use the two parallel lines um, to mean equal to, and he used two parallel lines because he said nothing could be more equal than two parallel lines. No two things could be more equal to each other than two parallel lines of the same length. So that's why that symbol is like that. And he was he was quite an interesting guy. He was he lived in Tenby in Pembrokeshire, and he went to the University of Oxford in about 1525. But he wasn't a mathematician as a profession. He was a doctor. So he did a medical degree. And then he returned to Oxford uh, and taught maths. So I don't quite know how, it's a little bit like my career, I suppose. I wasn't in medicine, but I certainly wasn't in maths either. Maybe it just comes.
Me too. Me
Yeah,
too.
exactly. If you just work long enough, eventually everything becomes maths, I think. But after that, he sort of went to London and was a physician to the King Edward VI and Queen Mary, and also a controller of the Royal Mint, and as controller of mines and monies in Ireland. So
Oh,
yeah, but he had a sad fate, unfortunately, Becky. He was sued for defamation by a political enemy. I don't know who that was. But he was then arrested for debt and died in the King's Bench prison, Southwark, in 1558. So,
oh,
yeah, I mean, how the mighty fall very quickly.
yeah.
But yeah, so that's when the equal sign, it didn't immediately take off, though, would you believe? It wasn't a smash hit straight out the door. It took another 60 odd years, 61 years, until it was used again in print in 1618 in a anonymous appendix in Edward Wright's English translation of Descriptio by John Napier, which means nothing to me, Becky. But that's the next time that we saw the equal sign, and then it became a little bit more popular after that. But it was a slow burner, as you know, as mathematical symbols go. It also had some competing symbols before that. So there was for a while the sort of the kind of parenthesis or bracket, but straight edged with sort of a looks like a capital C. That
Yeah,
was used.
yeah.
That was used
Oh,
for equality by French monk Johannes Bataillon in 1559. So after Robert had come up with the equal sign, and then in 1571, Wilhelm, a chap called Wilhelm, whose last name is spelled Xylander, Zylander, maybe, published a book in which he used two parallel vertical lines for equality. And that was actually adopted more widely to start with for the next sort of 100 years or so until, yeah, we came up with it was Robert's equal sign is the one that won out in the end, and is the one that we know and love and teach today. So yeah, so a little bit
wow.
longer than 150 years, but possibly not as long as some people might have expected, I suppose.
Yeah, I purposely went low because I
Yeah.
thought it was going to be a surprising answer. I was thinking, as you were saying before, you said about the vertical lines. I wonder why it was ended up being horizontal and not vertical. I was reading an article just today about more than less than symbols. We won't go into
Yeah.
that today, but somebody was suggesting about having a shorter and followed by a longer vertical line instead of the arrow. And I thought, yeah, funny that what we use
Well,
now is just normal, but
yeah,
it could have
I
been
mean,
different.
I suppose if the two vertical lines could easily be mistaken for 11, couldn't they? Or a 1 and 1 or
Yes.
something. Whereas putting them horizontally doesn't look like any other number or any other symbol, does it really? So I suppose it
Yeah.
makes sense from that point of view.
Great.
Yeah. So there you
Oh,
go.
that was a
Just
nice one.
well, I love a fun fact, Becky, and I end up going down these little rabbit holes of mathematical history. And yeah, I just think it's anytime you can give kids a little bit of context, a little bit of history, I think well, I just like to show off with it, really.
Yeah.
So yeah, I always try to encourage that in class. I think find out where things came from. A little bit like with your etymology, Becky. Sometimes that context can help you to remember, what it means.
Yeah, definitely. Bit of context.
So this is, let's move on. And we're going to talk about the top 3 trickiest things to teach in maths. And this took me a little while to come up with my top 3, Becky. I don't know about you.
Yeah, me too. And I did already see your list, John. So I tried not to choose this, although there would have been an overlap had we done it completely separately.
Yeah.
I tried to choose 3 different things just so that it would, add
Well,
a bit
I
more
did say
discussion.
we have to be quite specific because you could just say fractions or the 4 operations. And, difficult to argue with that sort of thing. But I think there are certain moments in when you're teaching maths and you come across a concept and you think, oh, yeah, no, I know that this is going to take me longer than you would expect, and I'm going to have to deal with some misconceptions. And something about it is just inherently tricky.
Yeah.
So yeah. So do you want me to kick off, or do you want to go first?
You go first. I think, yeah, you go first. And I think there's probably some agreement, but yeah, let's hear
Okay.
yours.
So I'll try and do them in descending order. Okay. So
Oh,
for for my third one, I went with comparing fractions. Now I could have gone with lots of things about fractions, to be honest, because I think they're just abstract in nature and not well or not easily understood. We spend a long time early in our learning journey, learning about whole numbers and how numbers are put together and how the number system works and place value and all of that sort of thing. And fractions can sort of blow all of that out the water, can't it? It can feel like a completely different kettle of fish.
yeah.
But there's something about comparing fractions which I think really challenges our understanding of what a fraction is. And I think if you've got a really good conceptual understanding. So I was cutting a pizza up last night, Becky, and I've got my 7-year-old daughter with me, and I said, right, okay, I'm cutting this into 6 equal pieces. What is each piece going to be? Totally ignoring the fact that they weren't equal pieces, because obviously I wanted the
I was
bigger
going to say,
pieces.
yeah.
I wanted the bigger pieces, Becky. But let's just pretend that they were equal pieces. And she said 6/4, which again, it just shows that she's got an idea of the whole has been split up into pieces, and we've got names for these
Yeah.
pieces. But she's not at start of year 3, hasn't got onto things more than halves and quarters. And we talked about it's not 6/4, is it 6 halves? Again, we're just grasping for things here. um and so I think you really have to have that conceptual understanding of actually really what does a quarter mean, what does a half mean. And then you can compare the two of them, can't you, and think, okay, if I really understand that, then as long as we're talking about the same whole, then I can see that a half is bigger than a quarter. I don't need to do any other maths than that, do I? I can do that. And therefore, I can see the 6th is going to be smaller than a quarter as well. So I think if that's really, really secure, then actually this bit isn't too tricky. Where it gets tricky is where the numerator becomes more than 1, doesn't it? And you're comparing
Yeah.
something like, I don't know, 7/8 and uh, 15/19 or something like that. And you think, okay, well, I know both of them are nearly a whole, but I don't know, I've got to then use multiplicative reasoning and proportionality and things to find common denominators. And there's so many steps to it that just having that conceptual knowledge helps, but doesn't solve it for you. You really do have to get to a
No.
procedure at that point to be able to work it out, I think. So I always encourage kids to compare it to a half first. Is it bigger than a half or smaller than a half? Will that help you? If I know it's 3/4 or 3/5, then I know that a quarter is bigger than a fifth. So if the numerators are the same, I can work it out that way. But at some point, you do have to have a procedure to help you. And so I
Yeah.
think that's where it can just become particularly tricky. So that was my number 3. That's my number 3. What was your number 3, Becky?
My number 3 was, well, it's an interesting one because it's something that I think some people find really easy and really straightforward and some don't. And it's the concept of an angle as a degree of turn. I think, when we first, and then I'm talking about when you first start talking about angles.
Yeah.
And, you do these things where you're going on the playground and you're turning and you're physically, lasers out of your eyes or arms in front of you or whatever you need to do. And I think the difficult thing here is that we've talked about spatial reasoning and things like that before, haven't we? But it's not the children that you would necessarily expect who might struggle with that particular concept of what that is. And it's when you start thinking about, well, is it a right angle? And we know we have tools, don't we, to help us decide if they are. But some people, some children and adults will just say, yes, no, that's smaller, that's bigger. And some of them find it really, really hard. And as somebody who just sees it, I have found that a very difficult thing to teach.
I wonder whether it is something to do with, because what a common misconception is that you're sort of measuring the distance between the two lines when you're measuring an angle, aren't you? And
Yeah.
to be fair, because that's what we often do with lines. We draw a line and then we measure how long it is, or we're given a line and we have to measure how long it is. So we've got this sort of inbuilt understanding that, you know, you can measure the length of a line, can't you, and figure that out. And then you've got these angles which sound similar, you know, they're going up in ones, and you can have a smaller than an integer, but generally we look at, don't we, you know, integers
Yeah.
for measuring angles and things. And you're measuring between two lines, so it sort of feels like it's a distance that you're measuring, but it's not a distance at all. It's a
No.
turn, and it doesn't look like a turn, because I know that if I turn myself, then, you know, all of me is facing a different way, whereas
Yeah. No lines
with these,
involved.
no, but these lines don't move. So yeah, I always used to get two rulers together and sort of open them up and show that, you know, we're starting from this line at the bottom, and then we're measuring how much it has turned. Yeah, I don't know if there's a better way than that, really.
No, I mean, I've done the outside lots on the playground. We've
Yeah.
drawn the line and then we've turned and then we've drawn the line. But I don't know. It just it's such an abstract concept, and some people really struggle with what a certain angle looks like. I think we get there eventually,
Yeah.
but when you first do it, I think sometimes it's like you say, it's so different to anything we've measured before.
Yes. Yeah. And then we complicate it by saying, you know, we can look at internal and external angles in shapes and polygons and things.
And are we going clockwise or
Yeah,
anti-clockwise or
yeah. And, you know, what do the numbers mean? And the protractor's just a totally weird piece of equipment, isn't it, compared to everything else that we've used so far? And you can have it backwards, and, you know, it's transparent. Yeah, it's just, it's something that I think just takes time to grasp. So I like
yeah.
that. Yeah, I can see that. But when you do understand it, it does make things a lot easier, I think. You know, you
Oh,
can rationalize that this
definitely.
can't be, you know, 180 or 170 degrees, because it's way smaller than a right angle. And obviously I'm reading the wrong
Yeah.
set of numbers and things. So yeah, understanding it does help, but getting that understanding is quite tricky. I
Hmm.
think just needs showing in lots of different ways.
Yeah.
So my second trickiest concepts to teach, I think everybody knows what my first trickiest concept is going to be, I'll be honest. But my second trickiest one was long division. Um, and I think it's tricky mostly, and obviously I'm talking as a dyed-in-the-wool year 6 teacher here. You know, I struggled through this for many years. I think one of the problems with it is that it doesn't seem like an easy way of doing division. You know, you need to, if my divisor is 27, then I've got to write out at least 5 multiples probably of 27. So there's quite a lot of work there to do in the first place, isn't there? You know, I can use shortcuts. I can look at 200. I could look at 10 times 27. I can halve that to get 5 times 27. You know, maybe I can just double it and double it again to get 2 and 4 times 27. But there's a lot of work there really to make this
Yeah.
easier. And then there just seems to be a lot of moving parts to it as well. And I think once you've got it, actually, it is quite straightforward, and you can see why it works. But until that point, it's quite tricky. And we used to use chunking, didn't we? And again, the skit
Yeah.
students that I was working with recently were very familiar with chunking. And what I quite like about chunking is that it does show you that um, that structure of repeated subtraction for division, you know, seeing how many times I can take away a chunk of the divisor. And so that's why I think chunking is still one of the stepping stones towards long division. But chunking isn't
Definitely.
necessarily a very efficient way of doing things. So, you know, long division is basically efficient chunking, isn't it? But there are places where you can go wrong quite easily, I think. And until you come across those things, you don't necessarily know that they're going to be a problem. You know, I'm thinking about when a zero or a couple of zeros appear, and I'm not sure how to handle these zeros in the middle of a number and things, in the middle of the dividend. So yeah, definitely, I've got slight trauma from teaching years of long division, Becky.
It definitely would have been on my list as well, John. I saw it on yours and thought, no, that's okay. I'll think of something else, but it definitely would have been there for me. And I think if we miss out steps earlier on, I think
Yeah,
people are very quick to try to get to a written method of division. If you miss out that important partitioning part and really playing around with the numbers and understanding what you're doing, it's going to be harder later. And I think that it's so
totally
important,
agree.
isn't it? Each
Yeah.
of the steps in that journey.
Yeah, you know my thoughts on this.
I do.
I've gone on about it enough. I don't need to go on about it again. But if I was to go on about it again, I would say that year 4 is a really important year for long division,
Yeah.
even though you're not doing long division in year 4. But anyway, we'll move on. I'm carrying some angst about that. What's in
Yeah.
second place for you, Becky? Trickiest things to teach in maths?
So I think I don't. Again, if you're a listener to the show, you probably won't be surprised by a measurement related one, and this is one which I struggle to see the point of.
Yeah.
But converting metric to imperial units
Now, we all know, Becky,
is
that you have got personal trauma with this. One of the first
I
ever
do-
episodes of the Primary Maths podcast, Becky held her hands up to, some difficulty with reading units of measure on a scale. So I can see why this has
yes,
come up.
yeah, personal trauma, and I just we do lots of converting within the metric system, and it's beautiful because it's tens and hundreds and thousands. And then you get to start looking at miles and kilometers. It's like, what is this madness? And obviously, graphically, it makes perfect sense. And that is obviously the way to look at it. But when you first start doing it, particularly if you don't, it's not a natural flair of yours to understand measurement, as is the case for me. Yeah, that is just, it's something that I would like to see gone from the curriculum, to be honest. But yeah,
Yeah, and it's interesting, isn't it? I think there's a lot of adults that don't have a real concept of how far a mile is, or even how far a kilometre is. I was talking to Again, sorry, but I was talking to my eldest daughter the other day, and she was saying, I can't remember why, but she was asking how far a mile was, and so I'd done quite a lot of running around the area that I live in, so but I always measure those things in kilometres because they're smaller, and so I can do more of them. It feels much
yeah,
better having run for 5K rather than 3 and a bit miles. So I knew how far a kilometre was, but I had to then have an idea that, okay, how much further then is a mile from that kilometre? I know there's 1.6 kilometres in a mile, so I've done a kilometre that I've got at least half again, haven't I, to get onto a mile? So there's lots of, I think it's quite interesting, but when you're in primary school, how often are you going to need that, you know,
yeah.
to memorize that conversion? I don't know.
And And later, I mean, some of the conversions are quite complicated, and I wish I've written it down now, but degrees centigrade to Fahrenheit is
Yeah,
something like 9/5 add 32 or something crazy
yeah.
like that. I just have a go-to in my head. I know that 28 is 82, and I just go from there
No,
rather than
28
having
is not
to.
82. Oh,
You sure?
centigrade and Fahrenheit, I see. Yeah.
Yes.
Thought you were just
Yeah.
getting your
20.
two
Yeah.
tally mixed up then, Becky.
I mean, anything could happen. We are talking measurement, John. So I could say
True.
any rubbish at
The
this
one
point.
I always
Um,
struggle with is ounces and grams. Like, people give me things in ounces, and I'm like, why are we still working in
yeah.
ounces? Grams so much more accurate, surely. But yes, okay. So I'll give you that one then. Converting units,
Yeah.
particularly metric and imperial, particularly tricky when you're weighing suitcases and things for a holiday. Um,
Yeah. And it really
so
matters.
I wonder if anybody has guessed what my number one trickiest topic to teach in maths is. It's not a year 6 topic for a change. You encounter it much further down the school. Now, I know you've seen my list, Becky, so I'm not going to ask you for a guess. But do you think you would have guessed this anyway if I'd
Yeah.
not? Yeah, yeah. So
Yeah.
at number 1 in my trickiest things to teach in maths, I have got teaching how to read an analog clock. Because I just think there is so much, particularly at the age that we're supposed to teach it, and given how infrequently children see analog clocks these days, I just think there is so much prerequisite knowledge and language that you need in order to truly understand how you read a clock. Now, my guest the other day, who will be on the podcast on Tuesday, Rob Eastaway, he said, it's fantastic analog clocks because there's so much maths in it. And I thought, yes, you're absolutely right. But who in their right mind would decide that you need to teach that to a child in year 1 or year 2? That there's so much maths in it, and that's the problem with it. There's too much maths in it
Yeah.
at that age. You're dealing with fractions, you're dealing with multiples, you're dealing with fives and tens, as well as ones. You're dealing with base 12 for some reason. You're thinking about 60ths. There's so much going on in there, and then the language of it, hands and minute hands, second hands, hour hands. Rob interestingly was saying, when you think about it, you don't really need a minute hand on a clock, an analog clock at all. The hour
No.
hand sort of does, and if you took off the minute hand, then conceptually it's a bit easier to understand what's happening. Actually, that the minute hand sort of complicates things really. You can see that if the hour hand's sort of halfway between the 5 and the 6, it's gone past the 5, it's half past 5, it's halfway. The minute hand just makes it a little bit more accurate. But yes, I could rant on about time for a long time. I'm not going to. There are other episodes of the podcast where I do that. But I had to put that at number 1, Becky, because it's definitely the thing that has caused me, as a maths lead, as a maths specialist, as a teacher, it's probably the thing that's caused me the most stress over the years in maths. So, yeah, that's my number 1. What did you go for then? What's your rival to time?
So, I mean, I think a lot of teachers would agree with you, John, that time is probably the thing that people dread most when they know it's coming up. But I went for, and it is very much a year 6 one, I'm afraid, or year 5, 6 one. But on the same note as fractions, that I love fractions. And I think once you know the bones of it and you understand conceptually what they are, you're opening up a whole world of maths. But specifically, multiplying and dividing fractions. Again,
Dividing
probably something
fractions.
you,
Ugh. Yeah.
yeah. And something you could argue maybe hasn't got a place in the Key Stage 2 curriculum, but it is there. And I think the difficult
Currently.
thing with this is because, for now, I think the difficult thing is that although this isn't necessarily true, when you first learn about multiplication division, multiplying is repeated addition, so we're getting more and more and more.
Yeah.
And division is repeated subtraction, so we're getting less. And then, of course, when you start multiplying by fractions less than 1, that has the opposite effect. And I just think, and there's some really good visuals you can use, but even so, I just think it's very clunky, and you end up, and well, we will all have known about little tricks that people get taught. And then, of course, there's no conceptual
Muddies
understanding
the
at all.
water even further, doesn't
It
it?
really
Yeah.
does, because it's then there's no understanding. We're just doing an algorithm that we
I'm
don't
sort
really
of
understand.
happier in some ways with multiplying fractions than I am with dividing fractions. I find the concept of dividing a fraction by another fraction really tricky because I feel almost like that's what's happening when you multiply a fraction by a fraction. You are dividing that fraction into, you say I'm multiplying a quarter by a quarter, I'm dividing that quarter into quarters, aren't I? So that sort of feels like division to me, even though I'm multiplying. And then, of course, you've got
Yeah,
the added thing of multiplying by an integer is a different thing to multiplying by a fraction. So you can multiply a fraction by an integer, and you have to do one thing, and that's conceptually a lot easier to understand, I think.
yeah,
3 lots of a quarter is 3 quarters. I can sort of see that. It's repeated addition again, like you say, isn't it, Becky? You've got a quarter, another quarter, another quarter. Put them together. How many quarters altogether? 3 quarters, fine. But then we've very quickly then got to introduce multiplying a fraction by another fraction, which again, when you think about what it means, I'm finding a quarter lots of a quarter. If we're doing a quarter times a quarter, that sort of makes sense, but it's tenuous, isn't it? It's very easy to
yeah.
get lost, I think, and lose that golden thread, that grasp of what it really means. So, yeah, I can see that. And then don't even get me started on division. Yeah, not a fan.
No, no. I just feel like there's so much fractions content, it's too soon for that. I personally, I think there's plenty more we can be doing with fractions before we get to that point.
So that's it. That is definitive. The definitive 6 trickiest things to teach in primary maths. We ought to have some sort of Top of the Pops countdown music on this for anybody who can remember what Top of the Pops is. You can see the reruns on BBC Two. Anyway, we have got in Becky's third trickiest concept to teach was the concept of angle as a degree of turn. Mine was comparing fractions. In number 2, Becky had converting units between metric and imperial, and I had long division. And at the top, the two trickiest things that we came up with was teaching time on an analog clock and multiplying and dividing fractions. Now, I know, Becky, this is going to be, even though I've said it's definitive, it's going to be slightly contentious. So if you are listening to this and you think they've got that absolutely wrong, I would love to hear what you think the trickiest thing to teach is. And the wonderful thing, Becky, is that, we might have somebody who teaches in reception who thinks, actually, you've got that totally wrong. Counting is the trickiest thing to teach because it's fundamental. And if you can't do that, you can't do anything else. But it is abstract. Requires rote memorization, all those things. If that's what you think, we would love to hear from you. Get in touch. You can email primarymathspodcast@twinkle.co.uk. It's twinkle without an E, or send us a message on any of the social media platforms. Or if you're watching this on YouTube, you could just drop us a comment in the comments section. So earlier this week, Becky, I was delighted to be joined by Phil Hurd to talk all about problem solving. And as is our wont on the AfterMaths episodes, we like to just discuss the key takeaways. So we've each picked out a couple of key takeaways from that episode. What was your first key takeaway, Becky?
So, first of all, great interview, Jon. I mean, you know that problem solving is quite close to my own heart. So I'm talking and thinking about problem solving a lot. Loved the interview. So could have taken away many, many things, as always. But I think one of the things that really resonated with me was the importance of struggle. I think it's something maybe we avoid a little bit. It's a bit tricky. It's not always easy to see children struggle. And I think in today's society, of instant gratification and getting what you need through the internet and finding it at the touch of a button, we are losing resilience, aren't we? Time in every area, we are losing it. So I think it's really important that children are experiencing that struggle and therefore building resilience. There's not always a very quick fix to something. And I think it's important. That's an important lesson.
We talk about resilience as a key skill for all sorts of things in life, don't we, quite a lot? But we don't necessarily talk about how you become resilient. We just want people to be resilient. But actually, it's not necessarily something that you're born with, is it? So it requires going through a little bit of struggle. And there's a slight tension, I suppose, because we talk a lot with Teaching for Mastery about breaking things down into very small steps that are easier to take and, trying to bring everybody along and getting that pitch just right so that we can be successful without, leaving anybody behind. But at the same time, you're quite right. There needs at some point to be something that we struggle with as well. And that can equally be a small step, I would argue. As long as the teacher, you've got a clear pathway through it that you can help pupils with. But I don't see anything wrong with letting them struggle for a little while first, as you say, because that's where innovation comes from, and invention and problem solving. That's where it comes from.
Yeah.
If you don't have a problem to solve, if you already know the answer, I think, as Phil said, if it's a routine thing that we've just done 2 weeks of addition, and here are some addition problems that require you to add things together, that's not really problem solving, is it? That's just another way of practicing what we've already done. So I think sometimes when we think, problem solving's tricky, it's tricky because we don't do enough of it in terms of actual real problem solving. So yeah, totally agree with you, Becky. I think that's a really good one. one of mine was that problem solving is not the same as just doing word problems, and I suppose I've just kind of touched on that there. You know, Phil talked about routine problems and non-routine problems, and I think that's really key. I think it's great to have some examples of word problems so that you're familiar with them, and they can be a good way of doing some intelligent practice of what you just taught. But I think we just need to recognize that that's not really problem solving. And you know, problem solving can involve word problems, but if they are just a reframing of what we've just done, that's probably not really problem solving.
No. And I think I've done a lot of talking with customers and colleagues around problem solving. And I think that is what a lot of people think about when you say, tell me what you think about problem solving in maths, not necessarily maths experts or specialists,
Yeah,
but you'll say, tell me what you think about problem solving in maths. The automatic thought is to talk about word problems.
yeah.
I think that's just what comes to mind. And I think you're right. That isn't, it could be, but it isn't necessarily real
We
problem
do know that
solving.
language can be a barrier, don't we? You know, you could have somebody who's very
Oh,
good at
yeah.
maths, but struggles with reading and comprehension, and therefore, you know, although the maths, we talk about this with we talked about it in the episode with Phil about SATs questions where, you know, the content is year two content in some cases, but it's dressed up in words that make it harder to access. So there is something about word problems themselves that are tricky, but I'm not sure that that's always a problem solving problem. I think it's more of a comprehension sort of problem.
Yeah.
And you know, problem solving itself can be tricky. So yeah, totally agree on that. Um, the other thing that sort of stuck out to me was this idea of what we value, and I know we've talked about this before, but particularly with problem solving, yes, the answer to the problem might be sort of the holy grail that we, you know, we want to get to. It's the reason that we're tackling the problem in the first place in some ways, but in other ways, actually, as the teacher, what we're valuing is probably those skills that we want children to practice and that resilience that we want them to develop. And so being really sure that we're recognizing that and that that's actually what we're valuing, I think is important too.
Yeah, and I think Phil was talking about it, wasn't he? And separating the just doing problem solving and teaching problem solving are quite different things. And I think one of the other things that sort of came across in your conversation was that we, as people who talk maths and do a lot of maths and have probably led maths, are probably maybe a bit more confident in the area of problem solving, maybe. But I think it is an area of a lack of teacher confidence and definitely anxiety. I think some people will say, I love teaching maths because there's always a right answer.
Yeah.
And there often is, but problem solving, particularly, is like you say, isn't about that. And I think teachers, we've got time constraints. We want to have things ticked off, but actually having the confidence to have a bit of a struggle, have lots of discussion, actually spend some time really unpicking what you're doing to solve a problem can be so powerful, but it's a very difficult thing to do.
And it goes back to, you know, what are we really learning here? Oh, you know, in a
Yeah.
broad sense, we're learning to solve a problem, but actually, we could narrow that down a little bit. You know, we're learning to conjecture, or we're learning to make generalizations, or we're learning to spot patterns, whatever it might be. That's
Yeah.
really what we're learning about. And if I don't get a solution to the problem, well, that's okay. But what have I actually got at the end of it? And if I'm sat there with nothing, then that's not great, is it? But if I can see that actually, you know, I've worked systematically, or I've, you know, tried different things, or trial and error, whatever it might be, those are things that need to be recognised as well, don't they? Not just, you know, celebrating those people that have got an answer, a solution to it at the end of it.
Yeah.
Anything else from yourself, Becky?
Well, I think what the only other thing was, well, there were lots of things, but these are transferable skills, aren't they? I mean, the art of convincing. Phil himself was talking about discussing or convincing somebody who was observing a lesson that actually he was right to include content from previous year groups. And actually, that convincing is something which we should be doing in maths, but also is actually a very powerful tool in real life to be able to
Yeah,
convince and prove something.
yeah. Definitely transferable into English as well when you're thinking about persuasive
Yeah.
writing and that sort of thing. You know, as you say, these are not skills in a vacuum, are they? They're important skills for life. So yeah, totally agree, Becky. And we know that maths is the answer to everything anyway, don't we? So,
Of course, we
um,
do.
yeah, we won't worry too much about that. Um, we're almost out of time, but did you have a maths of life that you wanted to share with us this week, Becky?
I do have a quick one if we've got time for it this
Yeah,
week.
always time for maths of life.
So I did have this massive life ready a few weeks ago, John. Obviously, I've missed the last couple of weeks of podcasts, so I would love to be able to give you the context, but I can't remember what it was now. But it was something from your interview, and we talked about times tables and thinking about numbers. And I was thinking just generally about numbers, like you do. And I was thinking about, how is it that there are some numbers we just will never forget. For example, childhood phone numbers, things
Yeah,
like that. And some numbers, maybe shorter numbers, that just will not stay in your head. We talked about 4-digit codes, didn't we, a few weeks
we
ago?
did pin numbers.
So I did a little yeah. So I did a little bit of a deep dive. And there's obvious reasons. If you are of my generation, you might have always picked up the phone and recited said phone
Yeah,
number, and therefore repetition and practice, or dialed it lots of times, you probably would remember it more. And also it could have an emotional significance to a great time in your life. But ultimately, when we remember numbers, we are remembering chunks and patterns. We don't tend, if you had to remember a 12-digit number, you probably wouldn't remember it all in one big chunk, because do you know how many items can be held in the short term memory, John,
is it
at once?
5 or 6, something like that?
Not far off. It's between 5 and 9.
Yeah, well,
So
I'm thinking
yeah.
about my own short-term memory, Becky. It's definitely 5 rather than 9, if I'm honest. But
Yeah.
you're right. There's 2 phone numbers that stick in my head, and one of them I know as 2 sets of 3 digits, and the other one I know as 3 sets of 2 digits. Um,
Yeah.
and I think the second one I know is 3 sets of 2 digits, because um, I don't want to give the number away because people will be able to access, everything that I have. But 2 of them are multiples of 10. So, for example, it could be, it's not, don't bother trying, it's not, but it could be 20, 30, 59, for example. And so I think I remember it as, 3 sets of 2, whereas the other one are not multiples of 10. It's sort of 6 random digits. And so I remember that as a chunk of 3 and a chunk of 3.
Yeah, and that's exactly how the brain works. It looks for patterns, and it will look for
Mm.
those things and help you to chunk it up in different ways. But yeah, it was just quite interesting. And I thought, if you were remembering a 9-digit number, you might do it as 3, 3 and 3, or 5 and 4. And it probably would depend on what the numbers were. Um, and just as an aside, really, I was talking to my husband about this because, like we do, talking about
Yeah.
maths. And he said, well, that's exactly what happens in blindfold speed cubing. Okay, so this is
Yet
something that I
again, we've
can't
got back
do.
to speed cubing, Becky.
Always.
Yeah,
There's
I thought
always a
it'd been
link.
a couple of episodes, but that's because you've not been here. So, yeah,
Yeah,
I've been
yeah,
missing that.
exactly. So it has to get back to the cubing. But he said that, so you have to remember sort of 20 characters or letters. You give all the algorithms a different set of letters, and they're in groups of 2, and then you put them together in groups of 6, and then that's how it works. And I thought, actually, yeah, that I could. I mean, I'm not going to attempt it. I don't struggle to do one with my eyes open and looking at the thing, but it's interesting how that transfers across to different things as well.
I think we should get a speed cubing expert to come in on the show and teach you
Yes.
how to remember these, and we'll do it live. We'll do it as a live stream, and
Oh
really put you
no.
under pressure, and see how many digits you can remember from those. But that
Oh.
that would be great, Becky. That would be entertainment for everybody, especially me.
I'm not sure it would. Yes, yeah, I think you would like it. I don't think I
I'll
would
ask our
like it.
colleagues and see what they think. And we'll go with whatever they say. All right. That's really good of you to sign up for that. Thank you. Yeah. Okay. Brilliant. I enjoyed that, Becky. That was a good episode. I enjoyed that.
Yeah, it's good fun. It was nice to be back.
It was. It was nice to have you back, and we covered a lot of ground as well. We did a little bit of history. We did top 3 times 2 trickiest things to teach in maths. We got some key takeaways from Phil Hurd's episode, and we also got a little bit of maths of life at the end there with how we remember numbers. So thank you very much. Yeah, I enjoyed that. I hope everybody listening enjoyed it too. If you did, we'll be back with another of these episodes next Friday. But in the meantime, I'll be here on Tuesday with my guest, Rob Eastaway, to talk about how he has spent a lifetime, really, or certainly second half of a lifetime, spreading the good word to everybody about maths and making maths accessible. He's written a number of books, Becky. The first one I think that came to mind was Why Do Buses Always Come in Threes? All about, the maths of life, really. He stole our idea before we even came up with it. And then more recently, he wrote a book on the history of maths in Elizabethan times and how it relates to Shakespeare, and why Shakespeare may have actually been an accountant. So, yeah, really interesting chat with him that I'm looking forward to sharing with everybody on Tuesday. So if you haven't already liked and subscribed, please do so. That'll mean that you never miss an episode. And also do get in touch with your trickiest things to teach in maths or anything else that you would like to share with us or any questions that you might have.
Yep, looking forward to next week's interview, Jon, and I'll see you next time.
Yep, see you next time. Thanks, Becky. Take care, everyone. Have a good week.